Welcome to EDU World Space.
Alright guys, doing problem number 108 in chapter 9 of Chemistry Central Science. So molecules that are brightly colored have a small energy gap between filled and empty electronic states. In the HOMO-LUMO gap, you can see this in exercise 9.104. Sometimes you can visually tell which HOMO-LUMO gap is larger for one molecule than another. Suppose you have samples of two crystalline powders. One is white and one is green. Which one has the larger HOMO-LUMO gap? So let's review what our HOMO-LUMO samples are. So our HOMO-LUMO gap is. So a HOMO is the highest occupied molecular orbital. That's going to be the highest orbital that has the highest energy orbital that has an electron in it. Your LUMO is the lowest unoccupied molecular orbital. That's the lowest molecular orbital that has no electrons in it. So remember the basic concept behind how how light works. So light is produced through electron transitions. So when an electron drops from a higher energy level to a lower energy level, the difference in the energy between those two levels, that is expressed as a specific wavelength of light. So when an electron goes from a higher energy level to a lower energy level, light is being produced. However, when an electron is going from a low energy level to a higher energy level, then that means light is being absorbed. So we have a specific color wheel to know this. So we have, remember the color wheel from art class, we have red, blue, yellow, green, orange, and purple. So we need to look at these in terms of complementary colors. So if you're absorbing red, you're reflecting green. If you're absorbing blue, you're reflecting orange. If you're absorbing purple, you reflect yellow, etc. So how can we? So we can know which. So broadly, we can tell. We can know the color of a specific powder based on the delta E of our HOMO-LUMO gap, because we're going to excite an electron in our HOMO level to the LUMO level. And the delta E in this transition, that's going to be the kind of energy the wavelength of energy that is being absorbed. So for example, if your sample is green, that means green is being reflected back, and that means red is being absorbed. Now for white, remember what white light is. White light means that all of white light means that all the wavelengths of color in the visible spectrum are hitting your eye. That's what white light is. Black means that all wavelengths of the visible spectrum are being absorbed. Now, when we talk about light, we are talking about a specific process. So electrons can go from a lower energy level to a higher energy level if they're being excited. They're given energy. That's by definition excitation, and these can be excited by light. So if we were to shine a light on something that's going to excite our electron from our HOMO to our LUMO, and then our electron can jump down to our LUMO, and then, when we do the first excitation, we're going to we have a certain absorption of light, and then when we see when the electron drops down from the LUMO to HOMO level, then we're going to see reflection of light. So we can think of this in terms of white light. So if we're seeing white light, that means your there's no absorption of electrons, and all light is being reflected back. So we can think about this. So we can think about it this way. We can us if that's true, then that means that when light is being shown onto a compound that is white, then the gap between the HOMO and LUMO is so large that your electron cannot be excited, cannot go from the HOMO state to the LUMO state, because therefore you cannot absorb, your sample cannot absorb any energy, so all the light you're shining on it will be reflected back towards you. So that means that white light is going to have is going to have a much larger sample that looks white is going to reflect all the wavelengths of light, not going to absorb any light in the visible spectrum. So that means that you have a very large gap between your HOMO and your LUMO. Conversely, if you are reflecting light in the visible spectrum, that means you have a relatively smaller gap in your HOMO and LUMO, between your HOMO and your LUMO, because you're reflecting light in the visible spectrum, as opposed to as you're reflecting light in the visible spectrum and you're also absorbing a specific wavelength of light, as opposed to if you see a white sample, then all of the light is being reflected, none of it's being absorbed. So that means that since we have two samples, one's white and one's green, the white one is going to have the larger HOMO-LUMO gap. So the white sample is going to have a greater gap than the green sample.